Happy Monday, everyone. We're on Unit 7, Day 1, solving quadratic equations. Please pause where you need to. I'm going to start with something that's not a quadratic equation. This is a linear equation. How do I know it's linear? I know it's linear because I have a 1 right here as the exponent. I can't see it. It's invisible, but this does make it a linear equation. We're going to solve it just like we did in algebra. Do that now. Pause. You should have subtracted 3 to both sides. You get 2x is equal to 6. You divide by 2, you get x is equal to 3. I want to talk about this solution a little bit more. And I want to talk about it in terms of a graph. I want to rearrange my original equation here. 2x plus 3 equals 9. And I want to make it equal to 0. Well, in order to make it equal to 0, I can't just replace that 9 with a 0. What I actually have to do is I have to subtract the 9. 9 minus 9 will get me 0. So watch here. If I subtract 9 on this side, 9 minus 9 is 0. What I do to one side, I have to do to the other because I have to balance it out. I have to keep this equation balanced, like a seesaw, right? I can't subtract 9 here and get 0 and not do it to the other side. It needs to stay balanced. I now have 2x minus 6 is equal to 0. Now this 2x minus 6 should look familiar to you. Something like mx plus b. I'm going to graph it now over here, and I already have it graphed for us. You can see my x-axis and my y-axis. My b is my y-intercept. I have a negative 6. My slope is my 2. So I'm going to go up 2 over 1, up 2 over 1. And you can see this x-intercept right here. Let me move it around. See what that's equal to. That x-intercept right there is 3, 0. Remember, why is this 3 called why is this x-intercept also called a 0? This x-intercept is also called a 0 because if I go up to this equation right here and I type right here and I say 2 times 3, which is 6, 6 minus 6 is 0. That's another reason an x-intercept is called a 0, because when I plug it into this equation, it makes it equal to 0. When I have it here, 2x plus 3 is equal to 9, it will make it 9 as well. What you're supposed to learn from this right now, and you should have, if you haven't, paused it and sketched the graph to see that, oh, look, there's a connection between a solution to an equation, a solution to an equation, and if we set an equation equal to 0, like we did here, and graph it. Again, we have a solution to an equation here. X is equal to 3. There is a connection to the graph. What connection is it? When I take that equation that I solved for and I rearrange it so it's equal to 0, and I graph it, that solution is also my x-intercept, or 0. That's what you should have gotten from this first slide. We know that x-intercepts are also solutions to equations. So knowing what we know about x-intercepts, what I want you to do right now is I want you to sketch this graph. You have an x-intercept at -2 and 1, and a y-intercept at -2. You need to be able to identify the solution to the equation. How do I know what the solution to the equation is? It's the x-intercepts. X is going to be equal to -2, and x is equal to 1. That's all you're doing today. Well, that's part of what you're doing today, excuse me. You're looking at a graph, you're saying where does it cross the x-axis at -2 and 1, and you're recognizing that those x-intercepts, those zeros, are also solutions to the equations if I'm going to solve it. Just like when I would solve a linear equation. We're going to learn now how we know how to solve a linear equation. Okay? You learned that starting in Algebra 1. We're now going to learn how to solve a quadratic equation algebraically. Right now we know that we can look at it and we can say the solution is going to be where it crosses the x-axis. Solve this equation by looking at the graph. So take a minute, quick sketch it. What do you notice about this graph? This graph isn't crossing the x-intercept or the x-axis. There are no x-intercepts. So what is the solution? There are no real solutions. So what should you learn from this slide? When it doesn't cross the x-axis, there's no real solutions. There's going to be something called imaginary solutions, which I'll teach you how to find later on this unit. Unit 7, Day 1, solving quadratic equations. Graph the quadratic and identify the vertex, axis of symmetry, and the zeros. What we're trying to get at here is that you can make a connection between your graph and finding the zeros, the solutions. Y is equal to negative times the quantity of x minus 1 times the quantity of x plus 1. This is an intercept form. The first thing I'm going to do is find my x-intercepts. How do I find my x-intercepts? This is all review for you right now. I'm going to take this factor and set it equal to 0. So I have x minus 1 is equal to 0 and x plus 1 is equal to 0. I'm going to solve for x there. When I solve for x here, I get 1, so 1 comma 0. When I solve for x here, I get negative 1 comma 0. Those are my x-intercepts. Next, I have my axis of symmetry. I take my x-intercepts, I add them together, I divide by 2. That's going to equal to 0. I have my vertex at 0, 1, and now I need to graph. My x-intercepts are at 1 and negative 1. My axis of symmetry is at 0. My vertex is at 0, comma 1. Pause where you need to make sure that you understand each step. This is review. Now, the zeros, one thing you need to know and you should write down, x-intercepts, zeros, and solutions, these are all the same thing. We want you to really understand that when you are solving a quadratic equation, okay, when you are solving a quadratic equation, you are really just finding the x-intercepts. So you can always graph the quadratic equation and figure out where it crosses the x-axis to figure out those solutions. Now, hopefully you can do it without graphing and you can recognize that, hey, I can solve this without graphing. I'm in intercept form right now. What do I need to do then? I need to find the x-intercepts. So I set each factor equal to 0, subtract 3, add 7, add 7. I have an x-intercept here at 7, and I have an x-intercept here at negative 3 over 2. Do I need to write it in x-intercept form? What's x-intercept form? That means as a coordinate, 7, comma 0. No, because our focus today is solving a quadratic equation, and that's saying what is x going to be equal to? X is going to be equal to 7, and x is going to be equal to negative 3 over 2. There are two answers there. All right, what do you need to work on right now? You have a sub today. She does know math, so ask her if you have any questions, but really, the homework is going to follow the notes exactly as I have it. You're going to be looking at different graphs. You just have to figure out where does it cross the x-axis. That's the solution to the quadratic equation. If it doesn't cross, okay, then there's no x-intercepts. That means there's no real solutions. It is possible it may only cross once. That means you have one solution. That means your vertex is on the x-axis. You need to be able just to remind yourself how to graph. Why do we remind ourselves how to graph? Because graphing is one way I can solve a quadratic equation. I figure out where those x-intercepts are. There are actually 5 different ways to solve a quadratic equation. We're going to go through all of those this unit. Finally, the last thing is if you're already in intercept form or factored form, just knowing that you don't have to even graph it. You can just set those factors equal to 0. Knowing that those are your x-intercepts, stop right there and say x is equal to 7 and x is equal to negative 3 over 2. Thanks, guys, and have a great day.